Alrighty, let's get this party started. Today, I want to talk about braids. This is KB Nuts and Braids Full 24, number 3, because we're talking about Braid Edition, which is almost undoubtedly the title of this video. If you want to find previous videos in the series, change this 3 to a 2 and plug it into Google search, and it'll find you a bunch of other stuff. Or you can just click on my name. That will also do the trick. Braid Edition. Let's talk about Braid Edition. So first off, we have to talk about braids. Recently, if you watch the previous 2 videos in this series, you'll see that we've been talking about knots, which are these really cool mathematical objects which function something like, which look something like this. They're not quite conventional knots the way you or I might expect them to be in nature. But the major difference is that we think of all sorts of knots as occurring in straight pieces of wire and yada yada, whereas in mathematics, knots are always tied at the end. As you can see, this is a complete loop, but it is untieable. You can try and find some way to untie it. Unless you cut this knot, you can't untie it. That's a very brief summation of some of the stuff we covered in knots. Right now, the more interesting thing that I'm going to do is I'm going to try and cut this. I'm going to cut along this line, and my claim is that if I do so, and I sort of suspend the remains of the knot between these 2 like anchor points or sides, then my result would be something that looks a little like this. Make sure I got my right number of loops, and there we go. So that's the basic claim of knots, and that's the basic claim that you can turn knots, if you cut them according to some very special ways, into this funky new thing called a braid. Now, these braids are, of course, the exact same sort of braid as we are dealing with when we're dealing with like hair braids. Those braids are usually involve 3 strands, and obviously here we just have what looks like a twist between 2. The braids that we can perform on 2 strands are less interesting than 3, but we'll notice an advantage right off the bat for this conversion in that this much more complicated sort of knot shape and figure has turned into a much simpler braid shape. So doing more complicated cuts for this sort of thing can be quite complicated. All I'm really intending to do here is introduce braids. So braids have a number of properties. Braids can be on any number of strands. So this, for example, is a 2-strand braid. We can draw our braids up and down like this, or we can draw them side to side like this. This is a 3-strand, a 2-strand. I've got a bunch of different techniques that I use for drawing braids. This one is also quite nice because it acts kind of like pegs, which is functionally very much how a braid addition specifically ends up working. And it's a good overall idea of braids. So here we have a slightly more complicated braid. Ooh, we have a crossing in our braid. So for example, here in this braid, we had 1, 2, 3 crossings. So this is a 3 crossing, a 2-strand, but a 3 crossing braid. And these basic sort of characterizations are a really important part of mathematics at all levels, basically. You're trying to figure out exactly what the object is so that we can manipulate it according to the basic important rules. What else do I want to talk to you about on braids? Let's talk briefly about doing basic braid addition. So let's take a simple 2-strand braid here. And then let's take another, put it on dots, and then let's take another simple 2-stranded braid. And what we can do is we can add them together. And functionally speaking, to add them together, all we do is we take these two parts of the braid and we like connect them up. So what does that mean? If we draw our dots back in here, here, and here, and here, hopefully it should be clear that all I'm doing is just connecting these braids end to end. Right? Now, this braid is kind of cool because once we add this braid to this braid, you can kind of see that these bits, this can just like pass over this other braid, and this underside can pass under the top braid, right? So that means that these two braids, when you add them together, they just unravel. This is a nice characteristic that we can use on braids so that we can sort of untie sections of them, but it's also just an obvious natural part of the braid. Normally, for example, if we were braiding hair, we can untie any braid by doing the same sort of braiding pattern, by applying some sort of braiding pattern in reverse to it. Not to give things away too much. You can also obviously just apply any sort of other real techniques and like pull your hands through the hair or whatever it is. But in mathematics, we're trying to create these sort of idealized objects that follow these different rules that we can then track down and perform and discover different interesting relationships with, as opposed to focusing too much on what the exact physical ramifications of a braid happens to be. These braid additions can end up being quite interesting, and you can do a bunch of different things with them. 2 braid additions are, I'm not going to lie, not that complicated. Aside from that, a braid addition, we can also add the same thing unto itself. So this is the same thing over again, same crossing both times. And if we do this, you should be able to see after a moment's intention that this does not unravel, unlike the previous piece. And instead we end up, let's make sure I did it all right, up, down, down, up, yep. And instead we end up with a 2 crossing braid. 2 crossing on 2 strands. We can take a braid and add it to a braid of a different size. So for example, we can take this braid over here and we can add it to this braid over here. To do that, all we have to do is pretend that this braid has an additional braiding connection over here, and then we can perform our summation the exact same way as we did before. So here it should just go, here I'm going to do it the slow way. And one more time, just in case people missed it the first time. There we are. And then straight across the top like so. The finished version of this braid is then nice and easy to simplify. It just looks like this. Now we're done. Important note about crossings. Ideally, and in fact always if you're doing it properly, crossings in the braid have a clear order. That means like this one, you can see that this one is in front of that one, or in this one, 1, 2, 3. It's easy to figure out which one is which. On a 3 or 2 strand braid, that's going to be less of a problem. But obviously once you start to deal with more complicated braids, that becomes a real issue. That's basic braid addition. The next thing I want to cover, the next exciting thing I want to cover with you is braid inverses. So we've looked at some cool braids. We talked a little bit about how to get from knots to braids. Braid inverses are cool. And braid inverses, I made a mistake in the knot videos. You can go check them out and find it out. But basically, what I said for knots that was wrong is true for braids. So braid inverses can be constructed using mirror symmetry. Here's how braid inverses work. Therefore, let me take this braid we just drew. If I pretend that this is my mirror, I'm still doing an addition here. I was going to not spoil things too much. Then I just reflect. And if you've got fast eyes, you probably already see where this is going. And in fact, what we end up with is a very similar sort of solution to what we had previously when I was just trying to make an easy example of an unwinding braid. And that's no coinkydink, obviously. Here again, we end up in the exact same position. This guy on top wants to move over that way. This guy on the bottom, both of these guys on the bottom, want to move under this way. And the end result is going to be an identity braid. So this braid, which we've seen several times now, is called the identity braid. And this is technically the identity braid on 3 strands. The identity braid can be on any number of strands. So a braid plus its inverse produces the identity braid. The identity braid can be on any number of strands. So 1, 2. That's an identity braid. We used sort of sections of the identity braid earlier when we were doing our addition on larger strands. What else do I need to tell you about the identity braid? Not a whole lot. It's pretty cool. The identity braid basically just expands as much as we want. And if we take, this is the last piece, obviously, if we take some section of identity braid and we add it to like any other crossing or knot, or crossing, if we add it to any other braid or any other properly cut up knot, what we end up with is just the original braid. So the identity braid plus not just this crossing, but actually any crossing will result in any crossing, or specifically this original crossing. I hope that kind of makes sense. We can express this on any number of sizes of braid. So for example, if I'm to come back over here and give one more idea of the this basic property of the identity braid, if you're not getting it, here I just take this simple braid, I can add it again to an identity, and if I draw this out, we see visual confirmation of the property that I promised was there. This clearly, again, just moves over these pieces, and there's no like change occurring here when it does that. The overall relationship between these braids is just going to be like that. It's not going to move all the way, sorry, it's just going to like reach equilibrium, right? We always pretend, basically, if I haven't managed to make that a bit clear, basically the trick to braid addition is pulling the ends of your braids clean. Pretending, at the very least. Pretending to pull on the ends of your braids. The trick is this untangles any of these sort of looping things, and then you end up with the final configuration of the braid. A mirror inverses will work no matter how complicated the braid pattern is, to my knowledge. I can, as always, do something dangerous and try and put my money where my mouth is and draw a braid. You got to be careful doing this. It's very easy to come up with much more complicated braids than you should. So I'm going to send that one over there. I'm going to send this one over there, and then I have no need for that top dot. Forgive me. But this looks pretty, so I'm going to try this. So this is a nice complicated one. As always, nice and dangerous to do this. Let's hope the construction works out properly. Let's hope I don't embarrass myself like I did last time I tried to do something like this on the internet. There we go. Now, if I connect those up, to be honest, that does look to me like we've successfully managed to create the identity braid once again. Take a look at that, double check it, see if your eyes tell you the same sort of information that they're telling me. And thank you so much for watching this video. I hope you have a fantastic day, and I hope you enjoy braiding and all the other cool stuff there is out there to learn and love. Thanks so much for being here. Bye for now.